Okay, so dice is thrown 50 times, and of course with the dice you've got the numbers 1 to 6, which can occur, and then here it tells us how many times each number came up, okay, and that's what frequency means, how many. So 1 came up 9 times, 2 came up 7 times, 3 came up 8 times, and so on. And you can obviously see here number 6 is the most frequent with 13. And then it says, part A, the relative frequency of throwing a 1 was calculated as 9 out of 50, which is 0.18, okay? So this probability here is based on these 50 throws, okay? So it's relative to this experiment. And yeah, number 1 came up 9 times out of the 50, so that's where that probability comes from. And we, of course, there's a decimal, there's 0.18. It says, what was the relative frequency of throwing a 6? Well, in the table, 6 came up 13 times, so that'll be 13 out of 50, okay? And they want it as a decimal, so you could use a calculator. 13 over 50, you could use the fraction button, as equals, as SD, okay? And that comes out to be then 0.26, okay? Or you could simply write 13 divided by 50, and same situation, 0.26. Okay, the number 4 was thrown 7 times in the first 50 throws. Using this fact, calculate how many times you'd expect a 4 to be thrown when this dice is thrown 3,000 times. So this is a sort of scaling issue, potentially, but if you notice here, I mean, they've got this result, haven't they, from the table, 7 times here, okay, out of 50. So the probability of getting a 4 is 7/50ths, okay? Now, what we can do is use this probability to calculate how many times it'll come up over 3,000 times, and you just multiply the probability by 3,000, okay? That's one way of doing it, probability. So we've got 7 out of 50 times then the amount of throws, 3,000, okay? And you get 420, all right? There is another way of doing it, all right? There's another way. If you're not happy doing it that way, you could just think, well, it comes up 7 times, okay, in 50 throws. Okay, that's essentially what occurs. So we can sort of scale this up then to get to 3,000. So, I mean, if we sort of say, okay, 7 times in 50 throws, well, in 100 throws, you're doubling the amount of throws, aren't you? So you'd have to double the amount of times it comes up, 14 times. And then you could go from 100, you could go straight to 3,000 by timesing it by 30. 30 throws, 30 times rather. So we scale it up by timesing by 30. You have to times this by 30, and 14 times 30, of course, comes out to be 420. Okay, so 2 ways of sort of doing that there. How many times would you expect a 4 to be thrown when a fair dice is thrown 3,000 times? Well, the probability of getting a 4 should be 1 out of 6, shouldn't it? Okay, you've got 1 chance out of 6 on a fair dice of getting a 4. So 3,000, right? Well, times the probability by the amount of throws. So 1/6 times 3,000, 500 times. Okay. The other way, of course, of thinking about it is the fact that 1/6 means you've got obviously one chance out of 6. So in a sense, we need to divide that 3,000 by 6, so each number gets represented, okay? And if you divide 3,000 by 6, you get 500 that way.